Okay, so in this final segment, I'm going to be talking about NumPy functions that you can use with arrays. And this is where hopefully everything starts to come together. So remember how in the first part I showed that some functions take arguments while others act on a target variable. Well, I'm about to introduce a lot of NumPy functions that you can use with arrays, and most of these, the majority of these, can be used either way. For example, the sum function calculates the sum of all the values in an array, and you can put that array as an argument in the parentheses. So here, np.sum of x gives you 46 as the result. Or you can call the sum function on the array. So here, x.sum also gives you 46. These both work, and you can feel free to use either syntax in this course. And just a quick note, most NumPy functions can be applied to lists as well as arrays, as long as that list is a valid array, meaning it contains a single data type. So here, if x is the list 10, 11, 12, 13, instead of an array, sum will still give you that same answer. Okay, so now you've seen the sum function. There are some other useful NumPy functions to memorize. There's the mean function, which calculates the mean or the average. And for this array here, that comes out to 11.5. Now there's also the median function. It calculates the median. It's also 11.5 here. There's the max function, which finds the maximum value in an array. In this case, that's 13. And of course, there has to be a min function that finds the minimum value, and that is 10 here. And finally, the STD function, the standard deviation function, that calculates how far the values in an array are spread out. And you'll notice all these functions take in an array, and they spit out a single number. Because of that, we refer to them as reductions because they reduce an array down to one number that describes it. Now, NumPy also makes some useful constant values available. And these aren't functions, but you still access them using the np dot notation. So for example, you can get the constant pi using np dot pi. And this evaluates to the floating point number 3.14159, et cetera. There's the constant e, Euler's number, which is about 2.718. And there's also positive infinity, or np.inf. And notice here that if you multiply 5 times np.inf, you just get inf back because 5 times infinity is still infinity. And lastly, there is np.nan, nan, which stands for not a number. You'll see this used later in this course as a placeholder for missing data, which happens pretty frequently. And similar to infinity, 5 times np.nan just gives back nan. So here's some more handy functions. Unlike the reduction functions that I just showed 2 slides ago, these ones are element-wise, meaning they take in an array and then they give back an array. So I should also say that they take in single numbers as well. And in that case, they'll give back a single number. So we have np.absolute, which finds the absolute value of a number or an array. And here that's, in this case, that's 2, 1. There's np.round, which rounds a number or array to a given decimal place. In this case, that second argument 1 means round to 1 decimal place. So you get 5.2, 5.3. Then there's the sqrt for square root function, which is the same as raising a number or array to the 0.5 exponent. There's the exp for exponential function, which is the same as raising the NumPy constant e to a given exponent or array of exponents. And then lastly, there are these sine and cosine functions, as well as a host of other trigonometric functions that I haven't listed here, which take in a number or an array of angles. And these are specified in radians rather than degrees. Lastly, in this very final slide here, I want to introduce some helpful functions that create new arrays. So there's np.zeros, and that creates a new array filled with zeros. of the length specified in the argument. So np.zeros parentheses 4 gives an array of length 4 that's filled with zeros. Similarly, np.ones fills a new array with the value just 1. And np.full creates a new array of the given length, this first argument, filled with a given value, the second argument. So this example here, that creates an array of length 4 filled with 2s. Now, np.arange probably looks familiar because it's similar to Python's range function, except in this case, it gives you an array instead of a list. In this case, the array 0, 1, 2, 3. And again, all these are arrays, not lists. And you can use either function in a for loop, range or arange. There's a difference, though, in that np.arange can have decimal values or floats for its start, end, and increment values. So a range of 0, 1, 0.25 starts at 0, it ends before 1, and it uses this increment of 0.25. That gives you 0, 0.25, 0.5, 0.75, and it stops before 1. And finally, np.linspace for linear space, or linearly spaced, returns an array of the length given in its final argument, evenly spaced out from the start to end values, which are those first two arguments. Now, except there's a difference from arange in that its end value is inclusive, not exclusive. So linspace from 0 to 1 with a length of 5 returns the array 0, 0.25, 0.5, 0.75, and 1 because it's inclusive at the end. Okay. That is it for this lesson. I'd encourage you to download the PDF version of these slides, which are linked from Canvas and Google Drive, so you can have all these functions handy as a reference this quarter. And I'll hopefully see you in class on Tuesday, where we're going to be writing some code that will show how NumPy can be incredibly useful for analyzing data.